Okay, so the next thing we need to look at is sample timing. Um, so this is really important because sometimes in ecology or environmental science, the thing we are looking at um, is happening at different times of the year or changes during a year or even a day. So this is the interval between samples, because we're not just going to do it once, we need to do it multiple times. So is it a long-term change? Is it going to be something like a change in population? So we need to come back like every year, perhaps. Or is it going to be a seasonal change? So it happens, it sort of changes throughout the year. So we need to come back and track a migratory species. So that's only going to come back at certain times of the year. Temperature changes with the seasons. Atmospheric CO2, that also changes with the seasons. So we might have to come back. Is it a sort of something that changes over a day, so a diurnal change? So this is over a 24-hour period, is sort of a day-night cycle. So this could be light levels, which again would change with seasons as well. It could be noise, so like road noise or something like that, that could change. Or it could be something that happens like the weather, which changes between minutes, or it could be weeks. It could be a mixture of many of these or much shorter. So how often do we need to do it? How often do we need to come back and do it? So the next one then is sample size. And this is a bit confusing. So you think, oh, sample size means how many samples it is. But no, what it actually means is how big a sample. Do we use a quadrat that is 1 meter by 1 meter? Because what we're looking at, it takes up quite a lot of space. Can we use a smaller quadrat that maybe is 25 centimeters by 25 centimeters if we're looking at just barnacles on a rock or something like that? How big is the thing, like what we're going to measure? Next one then is number of samples. Let's try that again and get rid of that. There we go, that's a bit better. So number of samples is going to be a minimum of 10. So if in an exam question you ask, like you need to mention the fact that it's going to be at least 10 samples, but it depends on how variable. So it actually depends on how variable the thing that we're going to measure. So if something is really broadly scattered and it's evenly spread, so if we have, for example, a field, and the thing we want to measure are these sort of red flowers, and if they're evenly scattered throughout our field, we can be confident that we'll have a representative sample with a relatively few number of samples. However, if we find we have a field where our red flowers are actually very clustered, we are not going to be confident that our samples are going to be representative of the true population unless we do a lot of samples. So the degree of scatter around our mean is going to affect how many samples we need to take. a good measure of this can be something like standard deviation, which is the measure of variance or variation around a mean value. Okay, this sort of would be shown, standard deviation is typically shown in a graph where we have our mean value recorded. So it could be a bar graph, for example, like this, or a histogram, or a scatter graph, and the standard deviation might be shown as like an error bar above and below it. Where it overlaps, it means that potentially these two values are not significantly different. Because we have a large variance or variation around the mean. And this in part could be produced by having not evenly spread things that we're measuring. The next one then is standardization of techniques. So this means that we are following a set method. Okay, how are we going to catch insects? How big is the net going to be? How big is the light? How bright is it going to be? How long is it going to be switched on? If we're doing kick sampling, using a net in some water, we need to follow the same method each time. So we're going to stand upstream in our big wellies, and we're going to stomp up and down and kick the sediment around for a set amount of time, so 2 minutes. And then we're going to pick up the rocks and give them a scrub to get off any benthic organisms. We're going to do that for 2 minutes. And we're going to do that in the same way every time we take a sample, for example. And then the last one is statistical analysis. What sort of statistics are we going to look for? And this will inform, in part, how you are going to set up your investigation. So we might have, typically we're going to calculate a mean value from at least 3 samples from each site. Remembering we're going to have 10 sites. We would probably calculate a standard deviation. And we might look at some more involved statistical analysis. So something like a Mann-Whitney U test or a Spearman's correlation or something like that to see if we can identify the statistical significance of a controlling variable over something else. Okay, so thank you very much.